ladies and gentlemen, here we go. Our goal tonight for lesson 3.2 is to solve two variable systems of equations using substitution. So lesson 3.2 takes a look at using algebra. We've used graphing, but now we need to rely on our algebra. So let's take a look at what that process looks like. We need to solve for one of the equations for either x or y, and we pick the easier one. The easier one means it has a coefficient of positive 1. So we're going to look for that. Once we've done that, we substitute the expression from step 1 into the other equation. So at this point, step 2, we've used both equations. Solve the new equation for its variable, get an answer. So we're getting an answer because we're solving that new equation. What we want to remember here at step 3 is that there's only one type of variable. So either all x's or all y's. Once you get that, you're going to plug your answer from step 3 into either equation and get your other answer. So at this point, you should have an x and a y. You should have an ordered pair because now you're going to check that ordered pair in both equations. So let's take a look and see what this looks like as we go through and solve a system of equations by substitution. So we have x minus y equals 3. And we have negative 3x plus 4y equals 2. Neither one of those is solved for x or y because neither one of them has x or y by themselves. So we're going to have to do that step 1 here. So remember, we're looking for something that has a coefficient of 1. Well, obviously, I can see a coefficient of negative 3. I can see a coefficient of 4. Here I see a coefficient of 1, kind of ding, ding, dings, and this one has a negative 1. In all honesty, you could solve for x or y in that first equation, but I like solving for x in the first equation because there's no division. I don't have to get rid of a negative. So if you notice, I'm writing each of the equations out side by side. This helps me with substitution because I can see that I go for full circle. I start with the first equation here, and I circle around and go right back to it. So when we solve for x, and you'll see what I mean here in a little bit. When I solve for x, I have to add y to each side. So we get x is equal to 3 plus y. This 3 plus y has to get substituted in for x. X equals gets plugged in for x. So now what I'm going to have here is negative 3 times 3 plus y. So our substitution looks a little bit different. It's going to look more like an expression than a integer value. And we have plus 4y equals 2. Now when we look at this, we want to stop and see, do I only have one type of variable? And yes, I do. I have y's and y's. There's no x's left, so this is an equation that you know how to solve. Distribute negative 3, so you get negative 9 minus 3y plus 4y equals 2. We're going to add these like terms, so you get negative 9 plus y is equal to 2. And then we're going to end it by adding 9 to each side. And we get y is equal to 11. And so what we're going to do now is take a look at what it says to do after step 3. We just solved, we got an answer, y equals 11. Now we have to plug that answer into either equation. What I like to do is take this y equals 11 and plug it back into my first equation. So if you guys see, this is what I mean by going full circle. We were over here on the left, we substituted it on the right, and we came back around and substituted on the left. Because what you're going to have here is x equals 3 plus, and then we have to plug in this 11 that we had here. 3 plus 11. And so what we get is x equals 14. So our solution here is x comma y, 14 comma 11. So let's get out of this split screen and let's take a look at what checking is going to look like with this problem. I need to plug 14 and 11 in for x and y in both of those equations. So I'm going to have 14 minus 11, and I want to know if that equals 3. Well, sure enough, 14 minus 11 does equal 3. All right? We now need to substitute into the other one. This is where our work sometimes gets in our way, so if we can kind of If I can kind of box some of this stuff up. Let's see if it's going to let me do that. Oh, we'll see, ladies and gentlemen, what's in here. All right, we'll see if it'll let me box it up. I'm sorry for that little glitch here. All right, guys, sorry about that. Hopefully we can keep from having any more technical difficulties. So we checked 14 minus 11 to see that it equaled 3. Now I have to take 14 and 11 and plug it in for x and y in the second equation. So I have negative 3 times 14 plus 4 times the 11 that we have. And I want to know, does that equal 2? So I'm trying to see if that's equal there. So we have negative 42 plus 44. You can just do that on your calculator. But yes, that does equal positive 2. So we know that that solution works. All right, so ladies and gentlemen, you can either pause the video now or do these when you're all done watching. But on page 135, the handout, remember this isn't in your book, this is in the handout, you need to do number 21. All right, let's take a look at one last example here. We want to solve this solution by substitution. And so we have x equals 2y minus 4. Notice we already have x equals, so this is going to be a really quick substitution problem. We have x equals 2y minus 4, and I have 3x minus 6y is equal to negative 12. So we're going to take x equals and plug that in for x. So that 2y minus 4 is now replacing the variable. So we're going to have 3 times 2y minus 4 minus 6y equals negative 12. We're going to check and see, do we have all one type of variable? We sure do. We have all y's, so we're going to distribute. We have 6y minus 12 after we distribute. And then we still have the minus 6y equals negative 12. Well, you know to combine like terms, and you can see that these are going to cancel. Now be careful here, ladies and gentlemen. Do not lose this negative 12 here. So we want to make sure we keep it as a negative 12, not a positive 12. Because what's going to happen is sometimes when we're using algebra, our variables are going to cancel out. And this is where we're going to find those special types of solutions. We looked at those in lesson 3.1. Remember, we sometimes have no solutions, and sometimes we have infinitely many solutions. And we talked about what those look like graphically. Well, now we need to talk about what they look like algebraically. And so algebraically, what that means is our variables are going to cancel out, and we're going to be left with either a true statement or a false statement. So let's identify what we have here. We have a true statement. And so because this is a true statement, everything is going to work. We're always going to have negative 12 equals to negative 12. We're always going to have a true statement there. And so what that means is that this is infinitely many solutions. All right? We will have no solution, so either the null set or no solution if we have a false statement, which means we have two unequal sides. All right? So your job now is to do the second on your own. It's still on the handout. Page 135, number 17. Ladies and gentlemen, I will see you in class tomorrow.